So what I'm going to do is, like I said, I'm just going to go through demoing some of this, and if you want, you can follow along. So there are two exercises here. Here I'm just going to quickly go through some of the new commands that we're going to use for the exercise. We're going to first look at staple, which is, we have looked at lots of segmentations, how to do manual segmentations, for example. And sometimes, you have manual segmentations done by multiple raters. And then maybe you want to get like a consensus segmentation, who is right, who is wrong, what's kind of the average segmentation of, a few people. We do that with staple, which is a published algorithm that does that. Then we're going to talk about split and merge. When you have a multi-label segmentation, a segmentation image where you have multiple labels, you can split those labels into separate label images, do something with them, and then merge them into a multi-label segmentation at the end. And we're going to see an example of that. And that's going to actually use the for loop that Phil mentioned. And then the other useful thing is when you have multiple images, maybe you have multiple images that each represent one segmentation label, and you want to output them separately, but you don't want to write out like 10 different O commands. You can use the double O, which will output multiple files at once. And then we have vote, which is useful when you have sometimes some automatic segmentation algorithms will give you probability maps of different labels, and then you want to combine them into a multi-label segmentation. You can do that with vote. All right, so now we are going to try some of these, and let's see, we have where's the, I want to get the handout open as well. Where's
Let me see.
Okay, so for those of you who want to follow along, just make sure one more time that C3D works. Just type C3D and see if it works, because for some people things crashed and then you have to set the path again and stuff like that. So, and then also make sure that you are in the right directory. So you're in session 10, so you want to go to session 10.
That directory is incorrect. It has the materials in it as well.
Yeah, it's missing
Okay.
materials.
Yeah. Sorry about that. So, well, you know where it is now. So you can go to the data directory. Okay, so I'm going to so here I am, PWD. I'm at the right place. C3D works. And what do we have to do? Let's see. So we have 3 images that are segmentations of the same image done by different raters. Rater 1 has done one segmentation, Rater 2 has done another segmentation, Rater 3 has done another segmentation. Okay, so this is not working very well, but that's fine. Let's see. Okay, so now we are going to use that staple command that I just showed, which is, it's going to, this is why it would have helped not to mirror, but that's fine. So we are going to staple together those 3 segmentations into one. And we are going to do that by saying staple 1, which is it's going to staple all the label ones. These are all label ones, so that's not a problem. And then after that, what we have then on the stack is a probability map. So we might want to threshold it at the 0.5 probability, and then give it a foreground value of 1, which is our consensus segmentation, and background of 0, and then we output it by -o in staple.nii.dz. Okay, so we can take a look at these images. So we'll do ITK-SNAP radar1. I'm sorry. We are going to load one of those images as the gray image and the one other one as the segmentation image. So it's going to look like this. This is also very useful sometimes to visually compare two different segmentations that two people have done, just to load one of them as gray image, the other as segmentation. So those were two of our candidate segmentations overlaid on top of each other. So let's now load the third one on top of it, and that's going to be slightly more different. Now, go through this data and radar 3. That's slightly different if you noticed. And finally, we'll see how our stapled image look like. That's a little bit different. So that's all. So that's what staple does. Okay, what do we have next? So we went through all this. We looked at the stapled image. So now we are going to go through some things with multi-label segmentations that I mentioned before. So we will load an MRI image, a brain image which is slightly different looking than the ones that Phil showed you. It's going to be called MRI1. This is what you should have. And then we are going to load a multi-label segmentation for this image, which is going to be segmentation 1 here. So you can see the tiny segmentation over there. That's the segmentation of the hippocampal subregions, which is a small area of the brain. Right inside here, you click on the blue label just to center it. And then, I'm sorry. And then one of the things Paul probably covered in the morning is you can then go to the zoom tab, select the zoom tool rather, and we'll set it to a 4 pixel per millimeter zoom. Just to bring it a little closer, you can just use the pan tool to just bring it in the middle a little bit. Okay, so there is our multi-label segmentation. So you can see there are multiple labels there, different colors, and then we're going to do something with it. So what are we going to do? Let's see. What does it say here? Okay. So we are going to use split and merge here. So like I was saying, split will split a multi-label segmentation, just like it says, into the component segmentation images. So right now, if we load here, we are going to load segmentation 1 into C3D, and we're going to split. What that's going to do is, to begin with, that's great. To begin with, we have only one image in the stack, right? Just the segmentation 1. As soon as I say split, that's going to be replaced by 10 images because there are 10 labels in that image. So now we got 10 images. So this is an example of how you'll then use a for loop. So we're going to say for each, which means do something for each of the images on the stack. We're going to smooth each of them by this amount, and that's the only thing I'm going to do. I'm going to end the for loop, and then you have the backslashes here to, okay, let me also use the backslashes just to show how that works. See, the command didn't actually run. It gave me back another what is called a secondary prompt, which is the arrow sign. So it continues.
Oh, sorry, I'm just gonna move your window. So can you move the window up here? It's hard to see in the back.
Oh, okay. Is that better? Is that better for people at the back?
Yeah.
Okay. All right. So now we are going to do double O, which is output multiple images at the same time. And this is very useful. So remember, we split the multi-level segmentation, we smoothed each of them, and now we got the 10 smoothed versions. And now we are going to output them all together. I'm not going to go into the details of the syntax here, but the %02D means use 2 decimal places and use just whole numbers. So what it's basically going to do is it's going to write out 10 files, or 11 files in this case, I think, that are going to be called label underscore 00, label underscore 01, 02, like that. And that's, as with any other output commands like the -O or this one, it's not actually going to touch the stack. It's just going to output them. And then, since we split, we got to merge. So what we did was we had the original segmentation. We smoothed each of the labels. And now we are going to merge them back into a combined segmentation. We are going to call this segmentation 1 smoothed. Okay, so that's the trackpad. Okay, so then let's load that up into Snap. It's going to look slightly different. As soon as I hit finish here, it's slightly different. We smoothed, so one of the, it's hard to see here, but one of the labels that was here that was very small, because of our smoothing, that actually went away. So that's one of the things. Okay, that's good. That's done. So here's another example of, this is actually maybe useful, so I'll just mention it. You see there's an error message. It actually didn't write the segmentation 1 smoothed image, the output image. We are still able to load it because it was already in the folder. And that's because if we don't explicitly say -O, it won't overwrite an existing file. Normally, if you just say a file name at the end, it's going to output if it does not exist. But it won't do that if the file is still there. So you have to actually be able to write.
That's a good question. So you had a multi-segmentation. You split them and smoothed them.
Right.
And then you merge them.
Exactly.
So since they're split and smoothed, when you merge them, there's a possibility of overlap between the segmentations. How does it deal with that?
Well, so it's actually going to basically do a voting. So at every location after smoothing, it's going to treat them as probability maps. And at any voxel, whichever label has the highest probability, it's going to be assigned that label. That's how it's going to merge.
We can load up one of those label underscore images.
Yeah. So what we could do is we could load one of those labels. One is the big one, so let's load that as an overlay. So so that's actually, I'm just using the changing the transparency of the overlay. That's the probability map of one of the labels. So you'll have similar ones after smoothing for all of those, and then they're going to be merged. Okay, and to bring back the segmentation. So Paul talked about these shortcuts, I'm sure, in the morning, how to make them go away and how to change transparencies. Those are all useful stuff. So next we're going to use vote. So as Phil was saying, so we're going to use a wildcard. So at this point we will have all those 10 labels that we split and wrote out into the stack. So it's going to load all of those images, and then you are going to vote. It's basically going to do the same thing as Marge did. But there is one crucial difference. Okay, so now we have voted and we have the recombined segmentations. This might be a little confusing, but I'll still mention. So in our original segmentation, let me load that, segmentation 1. Okay. So we actually have the highest label that is there, the actual label number is 13, but we don't have 13 labels. So some of the numbers are missing. For example, I don't know if there is no 10 you can see here. Okay, and everything else is there, it seems. Okay, so when you split and merge, it actually keeps track of what the actual labels were. So when you merge, you get back the same labels. So there was no 12, it's not going to produce a 12. Whatever was 13, it's going to remember that's the one that was 13. Whereas in vote, it has no such information. You're just loading 10 image files, and so it's going to assume they are going to be numbered serially from 1 to 10. And so after voting, what you're going to get is labels that are 1 to 10. So let's load that. Recombine. You're going to see some colors are going to change. You see that? That's because we have different colors assigned to different labels, and what the vote did was there is no more 13. 13 got assigned a different color because now it's 10. So that's something to keep in mind when you're using these, and then probably then using statistics of overlaps and volumes of each label. So labels can get reassigned by mistake if you're not careful. So here it says don't close your ITK-SNAP window yet because we are going to continue to use this image, I think. Right. Okay. So let me see what I had here. So now we're going to put all of these back together. Many of these commands that you learned, and some new ones to actually show a little bit more complex thing and something useful that you can do. So the goal here is to use a screenshot for either quality analysis. When you got thousands of images, you want to quickly go through them, or somebody has segmented many images in a big data set. You want to quickly see if they make sense or they're completely wrong, things like that, and also to produce images for publication. So in this case, for example, we had that big brain image and a very small area of that segmented. When you're trying to publish this segmentation, you don't want that whole image. You want only the area around where you have actually segmented. So basically, from those segmentations that are loaded in SNAP, I want to produce something like this that I'm going to put in a paper. So that's the gray image, just cut out around that area where we segmented it, and that's the segmentation. So how do you get there? And these are just 2D image files, JPEG, or in this case, PNG. So we're going to do that. Some of the commands we'll learn while doing this is trim, which will actually let us extract a subregion of an image. Slice, which will extract a 3D, whichever slice, because there are multiple slices, right? So you want to, which slice you want to show for the paper. Reslice identity is basically, it'll cut an image to match the space of another image. OLI lets you produce an RGB color overlay image given a gray image and a segmentation. OMC lets you output a multi-component. For example, in this case, we're going to output a RGB color image. Interpolation, Phil showed you, sets how you interpolate numbers, and flip is, it flips X and Y axis. Okay, here we go. This is really long. This is the real fun stuff. Okay, so I'm just going to go through this. Load the gray image, which we already have loaded in ITK-SNAP. Next thing I'm going to do is just massage this image so it looks better. This is also important for publication, and Paul showed you in the morning how you do it in ITK-SNAP. You drag those curves in the contrast window to make sure the contrast looks right, that kind of stuff. So it's the same thing that you're doing here, and Phil showed you the stretch command. So you're taking 0 to 98% here and putting them into the range of 0 to 255, and then getting rid of anything that's outside of that range with clip.
This is exactly what the auto command does. When you go in Snap and you go to the contrast window and you hit the auto button, it does exactly what Sandy just typed in.
Yeah, so that looks nice when you're doing it in Snap. So but now you can do this automatically to produce the figure. So now we have that nice looking image. You can load up how that looks by writing it out. MRI1 stretched clipped. I'm not going to load it for the sake of time because we have only 5 minutes, but you can load up that image, see if that contrast looks a little bit better. So now we are going to store it away. We're going to use it later. So as Phil said, with pop you can pop an image out of the stack, but in this case we are not only popping but we are remembering it as a shortcut. So you're popping and at the same time you're giving it a shortcut, which is GG. Then we're going to load the segmentation. So again, just reminding you, so we have a gray image, we already have the segmentation, we want to produce those nice little chunky images in the end. So now comes trim. Trim 10 cross 10 cross 10 box. What that's going to do is it's going to take this segmentation image and see where any non-zero segmentation is, which is right in that little area. And then wherever there is non-zero, it'll look at the boundary and just take 10 voxels in all 3 directions from that boundary and just cut out that portion of the image. That's what trim is going to do. We can output that segmentation 1 trimmed. You can look at it now. Okay, let me actually do that. New ITK-SNAP window. Actually, we're going to do it a little later because we need both trimmed images to really look at it well. Okay, so we got the trimmed segmentation image, and now I'm going to remember it as SS. So GG for segmentation, I mean gray image, SS for segmentation. These are Paul's shortcuts. Okay, we're going to now push the gray image that we had, nicely corrected for contrast and everything back onto the stack. So what do we have now? At the bottom of the stack we have the trimmed segmentation, and on top we now loaded the big gray image. But we want the same area of the gray image as we have trimmed off the segmentation. What are we going to do for that? First, in this case they're all in the same space, so we don't need to really change any numbers. We don't need any linear interpolation or anything like that. So we are going to say interpolation type is nearest neighbor, and notice that I just said int here. Phil showed you interpolation. A lot of the C3D commands have useful shortcuts. This is an example of that. And then what I just told you, just cut out the gray image in the same size and space of the underlying segmentation image. We use reslice identity. That's a command that takes 2 input images. Obviously the reference image that's at the bottom of the stack, and on top is oh man. Maybe I did that before also, so then it's not going to work, but thankfully all the images are still already there. Okay, so now after this we are going to yeah. What was that? Okay.
Just gotta keep typing the same
What?
line. Just backspace.
Yeah, let me do that. Okay, so now we got, where's the big one? I can go to the end. it's there also. At the very end is also the entire command. Okay, let's no, okay, fine. So that's MRI1. I'm sorry, -O MRI1 trimmed. So now we are going to go to our new ITK-SNAP window and open up those trimmed images. Where are they? MRI1 trimmed. This is the one we just produced with reslice identity. So it cut out that part of the image. And now we are going to load the trimmed segmentation. Segmentation 1 trimmed. They're in the same space. Something went wrong.
Oh, probably you need to run the command again because you ran it by accident and probably you changed it. No, just no. Don't delete it.
Well, I don't need that yet. So.
Oh, okay. I see.
Okay, let's see if I screwed up my file. This is the one. Okay, segmentation 1 trimmed. Okay, but the files that you have, that should actually load. I don't know what happened here.
Well, you need to load the gray one again.
Let me load MRI1 trimmed. It's the same. I don't think there was anything. No, I never loaded that. So okay, all right, that's fine. Let's just go through the command pretending it all works. It does. I mean, there's some typo probably somewhere. Okay, so now the trimmed. We went through to the reslice identity. We pushed the gray image, and then I'm just going to type NN. That's another example of a shortcut. Instead of nearest neighbor, reslice identity, I'm going to skip the -O. Now push back the trimmed segmentation one more time. And okay, so now here's the final two things. Actually, no, there is OLI. So now there are two images in the stack, the small images. For both of them, we want the slice that we want to display. So the slice command, what it's going to do is slice along the z-axis at a 40% level. You could also specify the actual slice number. So now we got 2D images on the stack, just slices, the appropriate slices. We're going to flip XY. In this case, it was actually not necessary, but sometimes these images are going to be upside down, so you might want to flip. We end the for loop. So now we got those two images. We pop those two. In this case, you could do it different ways, but we are going to reverse the order, I think. That's why we're popping it. We want to present to the OLI command the images in the right order. So, okay. Well, no, in this case, actually, I don't think it was necessary. So we are popping and pushing it right back. So that might be unnecessary. I'll have to go see if there's a bug in this. If you guys are going to run it, hopefully it will run as it is. We're going to change the type to unsigned character, and that's because the PNG output images take 0 to 255 values, so that's a range of unsigned character data type. And then we are going to remember the gray image is on the top of the stack, and so therefore we just write it out, the gray.png, and now we're going to have to produce the segmentation image, the 2D image. We're going to push back the segmentation, and here's the other command, the OLI command. What that does is it takes a label image file, in this case that's snaplabels.txt, which defines what color each label is going to be. And that's something Paul also talked about in the morning, where you give different colors and you can save out a label description file. That's what this is. And the 0.5 is just the transparency of the label overlay that you want in your final output. So once you have that, at this point, what it has done is it's taken the gray image, we pushed the segmentation on top of it, the cutout segmentation that is. We use the overlay command to produce an overlay image. And that image is actually a multi-component image because it's got RGB values. It's a PNG image, just a color image. And so, therefore, we are going to have to write it out as a multi-component image. So OMC is output multi-component, and it's going to write out the segmentation file. I mean that screenshot. And in the end, if everything went well, you're going to have those two images. So that's all I have for that. And just a teaser, just one more thing you have in your handout in the last page. You can do even more stuff if you combine this with some other utilities. So if you have a large data set, in this case these are thickness map of 70 or 80 subjects. They're all in a common space, but they all look different, as you can see. Each of these images was produced by a long command like that and put together as a collage with another utility that is freely available, let's say. So this is very useful, for example, when you're quickly trying to quality assess a huge data set. So that's all I have. Didn't go over too much.
All right. So no more command line. Close your terminals. All right. So I'm gonna talk to you about the new version of ITK-SNAP, and we're just gonna wrap up for the day.
So the files in your directory would be okay. I just found out what I did wrong over there. So they should load and should not say it's not the same size.
Sorry, I just want to. Okay, so I'm just tempted to back up what Sandy says. So this is something that we had a meeting not so long ago where, I'm obsessed with these hippocampal subfields. So we had 13 different groups who had different segmentation protocols for hippocampal subfields. And we wanted to do, they all segmented the same image with their own protocol. You can see the protocols are very different. And my job was to put together some kind of quantitative analysis and generate some figures. So all of this stuff was generated using C3D pretty much. And the utility that Sandy mentioned for putting together these 2D PNGs into a nice figure is called Image Magic. And it's has nothing to do with our group, but it's a free utility that's very, very complementary to this. So like all these kinds of overlap measures and different kind of group-wise comparisons between these different segmentations and all of these slicing commands. All of this is in a script that runs C3D in a few commands. And so when somebody submits a different segmentation or a new person joins this group, I can just rerun my script and I have these figures done in about 10 minutes. So it really can be powerful. Like, when Sandy shows just one image, why do you need to do this? You can just go and do a screenshot. But if you have to do a screenshot for hundreds of slices for many different subjects, it really becomes quite useful. So even though the commands are quite hairy, there's a lot of powerful capability.